Hello friends, welcome to this channel Dr.ARM's Chemistry. This is lecture number 152, and here we are going to continue the previous point, that is the brief history of organometallic compounds. We are going to continue brief history of organometallic compounds. So last time we have seen the brief history up to the year 1912 to the year 1910. So from this we are going to continue with the next event which occurred in 1917. In 1970, when William Slink prepared the first alkyl lithium derivatives. Prepared the first alkyl lithium derivatives by transalkylation of mercury, organometallic, by transalkylation of organomercury compounds. The synthetic capacity of lithium derivatives. Here, because of this, the synthetic capabilities of lithium derivatives eventually replace the Grignard reagent by providing the primary anionic reactive intermediate. For example, so these are the two reactions whereby the transalkylation means the RTG organometallic compound will show the replacement of this R. This R is reacted with this lithium to RLI. Similarly, in case of this lithium ion, Ma2Hg, these Ma groups are captured by this lithium. So you will get 2Li and this 82Hg. Grignard reagent are replaced by primary anionic reactive derivatives recorded in 1921. Here Thomas Midgley Thomas Midgley, working for GE Motors, introduced the use of tetraethylene. Introduced the use of tetraethylene. Tetraethylene as an anti-knocking agent in the combustion of gasoline. The next event is in 1930 when K. Ziegler introduced the preparation of organolithium. Prepare organolithium by simpler route, which was further fine-tuned by Gilman. So another scientist contributed here, which is Gilman, which was Gilman. So he fine-tuned the method, which this encouraged the wider use of organolithium compounds. So Gilman fine-tuned the process or method. Lithium plus PHCH2ONe, which gives PHCH2Li plus LiONe. Similarly, another example is RX alkyl halide plus twice lithium gave RLi plus LiX. So this is the important event which took place in 1930, which was contributed by Ziegler and Gilman. So they provided the route for synthesis of organometallic compounds by simpler method, and which was further fine-tuned by Gilman. Next event was found in 1938, when Otto Roelin discovered the hydroformylation. Discovered hydroformylation. That is the OXO process. First, use of organometallic compounds in homogeneous catalysis. This is the first use of organometallic compounds in homogeneous catalysis. So the example is C double bond CH double bond CH2 plus H2 plus CO in presence of cobalt catalysis. The two hydrogens are added here, one is going here and another is going to this carbonyl carbon. This carbon gets attached to this carbon. So it gives CH2 and C double bond O, where I here this H. Next event was recorded in 1943 when E.G. Rochon discovered the direct synthesis of organochlorosilanes. He discovered the process by which we can prepare the variety of this large number of organochlorosilanes. He reported that is discovered direct synthesis of organochlorosilanes, which was initiated the large scale production of silicones. Organosilicones. For example, that is twice CH3Cl plus the silicon with copper at 300 degrees centigrade gave the CH3 twice SiCl2. So this product was taken up to each percent yield. The yield was about 8%. In some additional products like CH3 twice SiCl or CH3 SiCl3, so they are also simultaneously present, but in small proportion. Next event took place in 1948. W. Rick discovered the nickel catalyzed acetylene trimerization. Discover the nickel catalyzed trimerization of acetylene. So here the example thrice are CH so this in presence of nickel gave R. So we can obtain in this way the primary product of this acetylene or its derivative. The next event was detected in 1951 when two groups of researchers simultaneously produced the cyclopentadiene iron is ferrocene, that is bis cyclopentadiene iron. So two groups were working simultaneously at different regions and both of them prepared, but they suggested sigma bonding. But later on, another group, that is Wilkinson, Fisher and Woodward, suggested the sandwich structure for ferrocene. So the two groups are like this. First group is of Miller, Thibault, and Tremaine. remain. Second group was up to Kelly and Pawson. This first group carried out the reaction between Ap plus Cp cyclopentadiene, and second group carried out the reaction between the FeCl3 and cyclopentadiene magnesium bromide. So both of them independently prepare this cyclopentadiene. Like this sandwich structure of kerosene was suggested by the three scientists, that is Wilkinson, Fisher, E.O. Fisher, and Woodward. So this was another important event. Next event was recorded in 1955 when Ziegler and Natta, K. Ziegler and G. Natta developed olefin polymerization. Olefin polymerization at low pressure, using mixed metal catalysts. Transition metal halides and this alkyl aluminum Al3. So this was also important discovery which was recorded in the name of Ziegler and Natta in 1959. When first stabilization of cyclobutadiene, of cyclobutadiene was carried out by complexation with metals. This is the structure, for example, C4, Me4, Na C4Na4 NiCl2 twice. Next event was recorded in 1961 when the discovery of viscous complex which reversibly binds oxygen. This trans-iridium complex IRCl CO PPH3 twice. 1963, which was recorded as the important event when the Nobel Prize was awarded for Ziegler and Natta for their outstanding work in polymerization of alkenes, olefins. So, Nobel Prize for K. Ziegler and G. Natta. K. Ziegler and G. Natta. Only 1964, when E.O. Fischer prepared the first metal carbene complex. Like this. This is first metal carbene complex of this metal W. In 1965, this is very important event when Wilkinson and Coffey in independent studies, separate studies, used triphenylphosphine rhodium chloride as a homogeneous catalysis for the hydrogenation of alkenes. Independently used triphenylphosphine PPH3 thrice RHCl as a homogeneous catalyst in the hydrogenation of alkenes. Our next event was recorded in 1968 when William S. Knowles discovered asymmetric catalysis. Discovered asymmetric catalysis whereby complexes containing chiral ligands complexes containing chiral ligands were used to catalyze the conversion of achiral substrates were used for the conversion of achiral substrates into chiral substrates into chiral products, we can say products with high enantiomeric excess, First system involves asymmetric hydrogenation. So the first system of this involves the asymmetric hydrogenation. The first system involves asymmetric hydrogenation of alpha acetamino cinnamic acid derivatives using rhodium catalyst. So we will show this with the reaction. This is the derivative of alpha acetaminophenamic acid. So this was used to obtain the enantiomeric derivatives using this rhodium as a catalyst in the form of RH, Di, Pa, MAP, MAP plus using H2 hydrogen and H3O plus. So it gives this enantiomeric product which NH2 so it gives L-dopa and F2. L-dopa and F2. So this rhodium catalyst contains triphenylphosphine derivatives. With its methodology. This is DIPA MAP. So with this, we will stop our discussion. But The brief history is further continued in the next lecture. Please do subscribe to this channel and also press the like button. Thank you very much for watching. Keep